Hello and welcome to part 2 of this series where we are doing a large-scale backtest and optimization on over 500 stocks. I got a very interesting comment below the last video from Rob Stewart. Thank you, Rob. Rob is asking why not doing a vectorized operation instead of using an iterative approach. As vectorization is a super interesting and also important topic, I thought this would be very nice to integrate into this series. Some people were rightfully concerned about mark-to-market value of open positions. In the first part, I just ignored open positions for the sake of simplicity. To be 100% correct, we should integrate them, and that is what we are also taking care of in this video. That implicates that our most recent trade has unrealized gains or losses. In other words, I'm evaluating positions which had a buying signal and no selling signal yet against the most recent close price. Important disclaimer: concepts shown in this video are not an investment advice. Video is for educational and entertainment purposes only. Before we are getting started, thanks a lot to Coursera for sponsoring this video. Coursera offers world-class, affordable, flexible and job-relevant online learning. In specific, I want to share the Google Data Analytics Professional Certificate, which will have you job ready within 6 months. So with that, aid your self-development or even choose a new career path for 2023. As you see, it has a 4.8 out of 5-star rating and over 1.4 million people are already enrolled. You do not need any prior experience and you are able to learn self-paced, which I personally really appreciate. So what will you learn in specific? You will gain an immersive understanding of the practices and processes used by a junior or associate data analyst in their day-to-day job. You will also learn key analytical skills such as data cleaning, analysis and visualization, and also tools, spreadsheets, SQL, R programming and Tableau. Also, to boost your CV or your LinkedIn profile after finishing, you are getting a Google Professional Certification, which you then can share. So sign up to enroll for a 7-day free trial of this course now with my link, which I will post below. Thanks again, Coursera, for sponsoring this video. Alright, let's get started. This is the backtest function we set up in the previous video. Quick recap, what does this function do? It is taking a price data frame, does the moving average calculation, and then is iterating over that price data frame. If we are not in a position, we want to check the buying condition. And if that is fulfilled, we are storing the buy price. So the price we bought the asset for. As we bought, we are in a position now, so we are setting the position flag to true. If we are in a position, we are checking the selling condition. And if the selling condition is fulfilled, we are closing the trade, and with that we can calculate the profit. And the profit is simply the price we sold for minus the buy price in relation to the buy price to have the relative profit. Then we are appending that to a list and set the position flag to false. In the end, I'm accumulating the profit in the profits list. And I have my capital gain. Now, in this video, we want to transform this iterative logic into a vectorized logic. A very interesting thing to do and also a challenging thing to do. So, first step, we need to find the first occurrence of the buying signal in our price data frame. So our price data frame is test, right? So this is, I think, Apple price data. So we pulled that in the previous video, right? Apple prices. So this is our price data frame. Now we need to find the first occurrence of the buying signal. So buying signal, straightforward, is SMA1 is larger SMA2. So the first time we have a true value here, we know that this is our first buying signal. We want to have a buy first, so we need to find the first occurrence of the buy signal as our first step. So how can we do that? We can use IDX max to find the first occurrence of a true value in an array. So IDX max will provide us the max value, not the max value, but the first occurrence of the true value here in this series. So you see, on 26th of May 2010, we are getting the first occurrence of the buying signal. Now to transform that into a Boolean array, we can just check the index of our price data frame being that first occurrence. So with that, we are getting an array containing false values and one single true value where we are getting our first occurrence of the buying signal. Now let's transform that to a series containing the Boolean values and the index as dates. So we're simply taking panda series of that and set the index to our index of the price data frame. So with that, you see you're just getting the Boolean array here and the dates as an index here. So let's store that and first buy. With that, we have an array containing one single true value where we have our first buying signal. Now, once we found out our first buying signal, we need to find out the other buying signals. The huge challenge now is to only find those buying signals which are relevant. Meaning, if I just screen for, let's take this one again, my buying condition, I'm getting all rows where this condition is fulfilled or not. But I only need those rows where there actually has been a change. So here's a good example. You have a true value here, but you have also true values in the subsequent days, right? Somewhere here is the true value and you need to extract that first true value, right? In our iterative approach, we were taking care of that with the position flag. Here, we need a logic to find the rows where we have changes. And the logic is to check the previous row for the value. So whenever there's a switch in true or false, we have a valid signal. Makes sense, right? So whenever it is changing, so SMA is above SMA2, and then it is changing to SMA2 is above SMA1, we know that we have a valid selling signal in that case, and vice versa the other way around. So how do we find those switches? We are just taking the difference between two rows. And before going into the real data, let me set up a simple example. I think that's easier to understand. So let's set up a series here containing, let's take false, false, true, true, right? And take this example as just an extract of our real data. So here we have false because our SMA1 is not above our SMA2. Same here. And then here it is switching. So here the SMA1 is above the SMA2. But on the next day it is still true because that condition is still fulfilled. But we are already in a position here on that day. So how do we get a true value here and a false value here? We can just take the difference. And how does it work? If I take the difference, I'm just subtracting row by row. So I'm subtracting this row by this row by this row, and so on. And a true value is always corresponding to a 1. A false value is always corresponding to a 0. So if I'm taking the difference here, true minus true, I'm taking 1 minus 1, and I'm getting a false value here because 1 minus 1 is 0 and 0 corresponds to false. If I'm taking it here, true minus false, 1 minus 0, I'm getting a true value here, and I got exactly what I want to achieve. So let's take a look at that, or let's take a look at that one cell below. And now you see, we have a true value where we should have a true value. And we have a false value where we should have a false value because here we are already in a position. Makes sense, right? Now, the tricky thing to understand here is if we apply that on this series, so we're just taking the difference. This is also working for the selling signals. Why? Because the same logic I just explained to you applies as well. Let me extend that example here to make this more clear. So false and false. Let's take this one. And now take a look at that. So here I have my valid buying signal, right? And this one is going to be false when taking the difference, right? So because I have a valid buying signal here, and then I'm still in the position on the next day because my short term is still above my long-term moving average. So that is not a new buying signal. So this translates to false here. And then on the next day, I have a selling signal because the simple moving average short term is not above the long term anymore. That is happening in this row. And here I'm getting a true value now because this is a true selling signal. On the next day, it is still the short term is not above the long term moving average. So I have still a false value here. But I already sold my position, right? So I'm getting a false value here. So it is also applying for the false values. Why is that? Because if you subtract a true value from a false value, you calculate 0 minus 1. This is ending up as -1, and -1 corresponds to a true value, right? So we can capture both effects by just taking a look at the difference. And to combine both, we are just checking, are my rows containing true values when calculating the row-wise difference, or is my first buying signal containing a true value, right? So I'm just using the OR operator here and then check for the first buy. And these are my real signals. So signals where I just get rid of the subsequent same signals. So I'm only having signals when there is a change. So my real signal. Now let's get rid of that. And now it's getting interesting. So my real signal looks like this. It is just an array containing true and false values. And the true values here are my trades. Simple as that. So I can simply index my price data frame for the real signal. So that should rather be real signals, but I'm keeping it real signal now. So if I'm indexing that, I'm getting my trades. This is my first buying date, extracted by taking the first buy. This is my first selling date, extracted because I took a look at the differences. Next buying date, selling date, and so on. So I can store that in trades. But before doing that, let's take a look at if that is really the case. So let's compare that with our iterative approach, which is 100% correct. So let's see if these are actually the trades. So we can just extend our iterative backtest function by printing out the index for the buying date. So I'm extending that with buy so that we have it more lucid. So I just want to see which signals I'm getting with my iterative backtest here. So let's copy paste that here. So backtest. So buy on 26th, sell on 31st. So let's compare. Buy on 26th, sell on 31st. Next one would be 21st September. Let's check. 21st September. Let's check the last one. Last one would be an open position. 13.3. 13.3. Previous trade 26th and 1st November. 26th August. 1st November. Works like a charm, right? So let's take this one here. And we have our trades data frame. Isn't that awesome? Now we still have to calculate the profits here, right? And doing that, I also want to cover mark to market here. As we just saw, we have an open position at the end, right? So how do we deal with that open position? This one here. I'm just doing it with a very easy approach. I'm just marking this one here, which is priced with this price, so this one here, against the current market price of Apple. So how do I get the current market price of Apple? That is simply in my price data frame, right? So in this one, that is simply the latest close price of Apple. Okay. So when should I do that? Well, when my trades data frame, so this one here, has an unequal length, right? Oh, didn't I assign it? Sorry. So we have 35, which is an unequal number, and that means we have an open position. That can only happen if we have an open position. So we're just using a very simple if logic here. So if the length of my trades is not equal, just using modulo here, then I want to have my latest close price. So I'm just creating a mark to market variable here. And now I'm just taking the last row of my price data frame. So I'm just taking the tail, the very last row, make a copy of that to avoid annoying warning messages. And then this M to M is looking like this. Let me show it to you. So I have this, and now I have no price. Why I have no price? Because I don't have the next days open here, right? So I'm simply setting the price to the close. You will see in some seconds why I'm doing that. So I'm setting my price, this one here, to the close, MTM close. And then I'm just appending this to my trades data frame. So I'm simply reassigning trades, use pandas concat function, and pass my trades data frame and my mark to market data frame, which is simply the last row of my price data frame. Okay, so let's execute that for now and take a look at the trades data frame. Now my last row is simply the last trading date, and then I have my price here, my sell price here, and my buy price here. Okay, and now how does the profit calculation work here? That's very simple. So you have row-wise, you have a buying and selling row, right? So this is a buying row, this is a selling row, this is a buying row, selling row, and so on. And that is always the case. Why is that always the case? Because I'm making sure by taking a look at the first buy variable, or that I'm indexing the first occurrence of a buying signal, that my first row here is always a buying row. So what do I have to do? I simply have to take the row-wise differences here, but in this special case, only every second row, right? I want to do the following. I want to take this one, so the sell price minus the buy price, and then set that into relation to the buy price here. But I don't want to take this one minus this one because it doesn't make any sense. This is a buying signal, this is the previous selling signal. So I only want to take every second row here. So how can I do that? I'm just taking the price column here, then take the difference, so the row-wise difference, but I'm only taking every second row here, right? So this is looking like this. So you see, if we are just taking the prices, this minus this will be this, and so on. So with that, I have my absolute profits. These are just contain my absolute profits. And now I have to set that into relation to my buy price. And my buy prices are simply every second row starting with the very first row. So here I'm starting in the second row because the second row is my selling, my first selling price. So I'm just setting that into relation to trades, price, and then starting at the very first row, then every second row, and then take the values. So these are just the relative profits. So let me show you once again what I'm doing. I'm just taking this column here, take the difference of this and this, so this minus this, and I'm only doing it every second row. So to the next calculation would be this minus this, this. So I hope I'm in the right row. So this minus this, this minus this, and so on. All right. So we have that. We have the relative profits. So I'm just dividing that by every second buy price. So this, 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 and this, starting at this price, and with that I'm getting the relative profits. Okay, so these are my relative profits, and we can just calculate that here. Profits equals this, and then the capital gain, same as before, just the profits plus 1, and then the products. So gain would be 9.69 for something. So do we have the same for the iterative approach? No, we don't, but it makes sense because we didn't integrate the mark to market in the iterative approach yet. So I'm simply doing that quickly. So I can get rid of that for now. And now mark to market approach for iterative is very straightforward. So if you, after the loop ran through, are still in a position, so if in position after the loop went through, you're just taking the profit by taking the very last row, which is row, because the loop went all the way through and row is the last row. Just take the close, subtract the last buy price, set that into relation to the buy price, and then append it to the profits list. So this is containing mark to market. So let's see, 9.6943, and we got 9.6943. So exactly the same result using a vectorized approach. So finally, let's wrap that all in a function. So I'm cleaning up in some seconds. So let's call that vectorized. This is taking a price data frame and an M for the windows, so short-term, long-term, moving average. Then this is calculating the moving average, df and M. Then we have our first buy, just copy pasting now and make some changes. So first buy, series of the provided price data frame, then check if the short term is above the long term, take the first occurrence of that, then transform that to a series. Then the real signal is the first buy or the difference of the short term being above the long term. And then you have a trades data frame, which is simply the price data frame screen for the real signals. And finally, you're just doing this one here. So I'm just copy pasting that. So this has to be intended. So if length, this has to be df. Stays the same. That should be fine. And yeah, don't mess up with the levels of annotation here. So finally, I just want to return my gain here. So did I forget something? Doesn't look like it. Let's test that. So vectorized on test and 50 and 100, we are getting the same result here. So yeah, you can just use this function now to do the loop over all assets. So just copy paste this one from the last video, create the sub data frames for all assets, and then just exchange backtest with vectorized. And then you have it for all assets. All right. And I already made a speed test. This is taking 1/50 of the time from the loop using the iterative approach. All right, so you already see it's going through for 500 assets in like a few seconds. So yeah, I think this video, or I hope this video was interesting for you. If you have any questions, let me know in the comments below. Please like the video, comment on the video, and yeah, I thank you very much for watching, and I'm looking forward to see you in the upcoming videos. Bye bye.